Good morning, Tehmina Khan is here in TKMaths S1. In today's video, we will continue our lessons on A-level mathematics mechanics. Now this is the last topic. The rest of the topics are all in playlist. You can see in the description below. So the last topic is work, energy and power. I'll make 5 videos on it. The first video will cover the first 3 concepts. So let's start what is work. So in a layman language, we all understand whenever we do some work, either I'm studying, I'm exercising, I'm cutting something, fruit, vegetable, I'm doing work. But when we are talking about mechanics, we have a specific definition, a specific meaning, right? So we need to understand what is this. So in mechanic, work is done by a force when that force causes an object to move, okay? So when you apply force, an object move, then we say work is done in mechanics. Number one thing, because you should understand the basic concept behind everything. Now, if we are applying force, number one is its unit is Newton. And when it is moving a distance, for example, here I am representing it by letter S. So the force which is applied, the distance to which the object has moved, distance is measured in meters, then it is called work done, and the unit of work is joules, right? Now, next thing is, let's see this definition with a simple diagram so you can understand. We have seen this. But in this case, if you notice one thing here, the force is applied horizontally. An object is moved horizontally. This is one situation. Let's see another situation. Object is on the horizontal plane. Force is applied but at a certain angle. So now if the object is pulled by a particular force which is acting at certain angle, an object is moving horizontally, then your force component in the direction of the motion will be F cos theta. Agreed? Because we have already learned how to find out the component of the forces in the previous lessons. So now the force is not just F, it is F cos theta, and distance moved is D. Or if you are representing it with S, you can use S. So basically you get F cos theta, this is your force component, into D. So usually we write F D cos theta. Correct? Now, next topic is, or concept is, work done against gravity at a constant speed. Now you need to understand what is the meaning of constant speed here. It's very important. Whenever the body moves, here I am showing you with the help of this diagram. Whenever a body moves at a constant speed, it means a force is equal in magnitude to the force of resistance acting on it. So right now your weight is of this box is mg, which is down, mass is m and weight is mg. So upward force will be mg if it is moving up with the constant speed. Correct? So now, so if you're talking about work done against gravity when you are moving it up with the constant speed, so according to the definition, the work done is force into distance. So in this case, your force will be mg, and distance if you are representing by d or by s, your choice. Let's see one example here. By the way, these are the small examples. When we will do past paper, because it has mixture of concepts, it mingles many things. So that's why we are doing it one at a time, and then we will merge them. Question is, find the work done against gravity when an object of mass 3.5 kg is raised through a vertical distance of 6 meters. Okay, so for example, this is my object here, 3.5 kg. Okay. And force is applied on it. And because it is 3.5 kg as written in the question, so it will be 3.5 times g. G is the gravity, and in M1, now it is depending on the examination board. Some boards use 9.8 and some boards use 10. So accordingly, you will use the value of g. And this object has moved 6 meters up. Okay, it has come all the way till here. So the vertical force required is F. And what is the work done? work done is force into distance, okay, displacement, and is equals to 3.5 g, because I'm talking about force, into 6. Let's pick up the calculator. So 3.5 into g into 6 is 205.8. And joules is represented by J. So the work done against gravity is 205.8 joules. Correct. Now, next example. A horizontal force pulls a body of 2.25 kg distance of 8 meter. Now, please remember, it is a horizontal force, right? Across a rough horizontal surface. These are keywords. We have already studied about the friction. Now, coefficient of friction is 1 over 3. The body moves with a constant velocity. Another very important thing, in that case, the frictional force, the maximum frictional force will be applied. Now, let's see the diagram of the same question. I have drawn the diagram here and then I will solve the question. Question I have not solved yet. I will solve in front of you. So now, just for the sake of recall, why did I write here mu r? Because when the object is in motion and it is on the rough surface, then the frictional force is always maximum, which is mu r. We have studied in the topic friction. So I can say here the frictional force is mu r because the body is in motion on the rough surface. And if I resolve vertically, then this r, which is normal reaction of the body and the surface, will be 2.25 g. So it will be same, 2.25 g. And if you are taking g10, then it will be 22.5 Newton. Correct. So work done against friction will be what? It is force into distance moved. Okay. Now if it is force into distance moved and force is equals to mu r, because the object is moving with a constant velocity, and distance here is given in the question 8. And mu is given to us 1 over 3. R will be equals to 2.25 g into it. Now please pick up the calculator. Let me do this calculation. Okay, so it is coming 58.8 joules. So work done against friction is 58.8. Right? Okay, now let's see example 3, which is for work done against gravity and friction. Now, very important thing is, if object is on the ramp and it is on the rough surface, so you have to calculate the work done against gravity and friction both separately and then add it up to calculate the total work done. Let's try to understand this concept with the help of this example. Now, if you notice here, the inclined plane is at tan inverse 7 divided by 24. So this ratio will help you to understand the inclination of the plane with the horizontal. A body of mass 5 kg lies on the surface and it is being pulled by uniform speed at a distance of 75 centimeter. Now this is important. We have seen in work done, when we put distance, we write it in meter. So we will convert this 75 centimeter into, so it will become 0.75 meter. Correct. Or we can write 75 divided by 100 meter, whatever you can write. Now what is happening? The coefficient of friction given to you 5 divided by 12. And work done against gravity you have to calculate and against friction you have to calculate. So let's put this question in the diagram form. So here is a diagram. Tan theta is equals to 7 divided by 24, which is given here. With the help of this ratio, if I just draw a triangle here to explain it to you, by applying Pythagoras theorem, I can easily calculate the hypotenuse. Let me use the calculator. Okay, so it is 25. So sine theta will be equals to 7 divided by 25. And cos theta will be 24 divided by 5. We will see where do we need to use it. Now, if we are calculating work done against gravity, it is force times vertical distance moved. Okay, vertical distance moved by the object. Now, if suppose this is the starting point of the object, then vertically the object has gone up from here till here. This is the vertical distance, right? And it will be theta because these are parallel. So if this is my vertical distance d, then cos theta is equals to d divided by 75 centimeter, or I can write 0.75 in meters. So it will be d is equals to 0.75 into cos theta. So I can say force is basically the weight of the box, which is 5g. Okay. And vertical distance will be 0.75 into cos theta. And cos theta is equals to 24 divided by 25. Now let's pick up the calculator. So it is coming 10.29 joules. So this is the work done against gravity. Okay, now we have to find out the work done against friction. Now work done against friction, object has moved this way because it is a constant speed. So the force here will be equal to the maximum frictional force. So when I will find out the work done against frictional force, I will say force into distance. And my force will be mu r here because this is the, or it is equivalent to the frictional force. And distance will be 0.75 because we have to write in meter. Now mu is given to you in the question. It is 5/12. Now what is r? The value of r I will write here, and it will help me to find out the work done against friction. So now resolve perpendicular to the plane. So we have already seen it in the diagram. If I see here, if I resolve perpendicular to the plane, please pay attention. This is theta. What is this? Because r is equals to this. So this part, if I see here, is equals to 5g cos theta. Correct? 5g cos theta. So r is equals to 5g cos theta. So if your frictional force is mu r, then r is 5g cos theta. And cos, you already know. Cos theta is what? It was given to us in the question. 24 divided by 25. Now pick up the calculator and you get the answer exactly what I am getting. It is 14.7 joules. Right. So with this we will end the video. So now there is a test for your understanding. I have solved or put the solution of both the question. You can put the video on pause and answer these two questions, and let's see how much you understood. So I'm showing you the solution here. You can put the video on pause. Yes, you are absolutely right. The mass does not move, so there is no work done. Zero work done, right? Now let's see this second question. Again, take time, solve all the parts of it, and then I will show you the solution of it. Okay. So you can match your answer. I hope you have done it right. Congratulations. Thank you so much. So in next video, we will talk about energy and afterward power and then past paper questions. So thank you. If you have any question, any query, you can put it in the comments. Take care. Allah Hafiz.